I am just going to do that. In lieu of that, I shall ask for agenda items.
I've got 3 or 4 minor things just to update the group on a couple of things, Hamvention and similar items. Nothing that'll take too long.
Guess we'll see if there are any updates from John.
Yeah, I could probably throw something in there.
That sounds good.
Semi-permanent update registered in the agenda. Let's. Anybody else? This might be a short one.
I'd be okay with that.
That's fair. Gary, do you want to talk about Hamvention? Take it away.
Sure, let me share my screen. I'll bob through a couple things real quick. Let's see which screen and okay, so started a Hamvention page for HamSci. I'm going to work on a excuse me, another page for to recruit booth volunteers, and we can sign up for it, and pretty much what's been done in the past. So I'm just building on that. Anyhow, I thought it'd be worthwhile at least just to show you what we've got lined up for talks right now at times and dates. But I think more importantly, the people that are here, to make sure everybody who's on the presenter list is actually going to be there, so we don't surprise anybody. I think this guy will be there. I'm not too worried about him.
Yeah, and actually you can add another one for me, because I just got invited to be the banquet speaker for the Tapper AMSAT dinner too. And the way they invited me to do that was I got an email from John Ackerman saying, it just said, "Are you going to be at the Tapper AMSAT banquet on Friday night?" He's like, "I think you will be." I'm like, "Yeah, I'm planning on being there." He's like, "Great. The presentation will be 45 minutes long." So he didn't even ask if I wanted to do the talk. He just said, "Are you going to be at the dinner?" Great, you're speaking. So.
Oh, I don't know if I am going to be there on that weekend. So that's a question mark at this point.
Okay. Well, Rachel can stand in for you. Because Rachel is
find me.
Rachel's the new Grape project flag waving person.
Right. I don't have nearly the expertise, so.
That's quite.
That won't take long. Trust me.
Yeah. You have enough to give, because that particular talk, you're supposed to stand up there and say, like, you'll only have maybe 3 minutes to say anything in that talk if we're including all that stuff in a 20-minute presentation. So you basically, John can give you 2 or 3 slides about where things are with Grape 2, and you just flash those slides on the screen and say, "These are from John Gibbons. Here's what he told me to say," and that's it. And then you sit down.
Okay, so John, I'm aware you've got a question mark on there, and we obviously adjust as time gets closer. Or do you want me to take you out and just put Rachel in now? I can do that too.
It's got a conflict, so go ahead and put Rachel in.
Okay. I'll edit that, no problem. Okay, let's see, that was one thing.
And I can also say, Rachel, if there's someone else from Case Western who you'd like to give that update, like if David Kasdan is showing up, we can spread it around. So
right,
because you are talking in the slot before, so there's flexibility here.
Yeah, it does. I don't think it would be too bad.
Okay.
Okay, another question on the website is, and I can't remember if I've seen it or not, do we have a kind of a HamSci glossary page on the website?
We have one that was started on Google Drive. And if you go to, I think, let's see, is it on this year's HamSci workshop page? That's definitely on last year's. You go to the agenda page. Yeah, it's very sneakily hidden. if you go to this year's Hamsci workshop agenda page, I'll put the link in the chat there.
So hidden you can't find it.
It's so secure.
The reason I asked is that was one of the suggestions. I forget the context last week. Oh, when I was talking about some of the articles for QST to be able to point to some sort of a glossary. So I wanted to see what we had before I dropped that into the article.
Mm-hmm. So yeah, I put a link in the chat to the agenda page.
Okay. Okay, well, I'll find it. I know where it's at and I'll find it. I'll
Well,
take a look at it and see what we can use.
Here, just go to hamsci.org.
Okay. Come on, you.
And click there. And click agenda, workshop agenda. And then you see in the upper left-hand corner in tiny print, it says Hamsci glossary.
Okay.
So this is actually a fully editable page. So,
Okay.
Secret decoder ring.
Yeah.
Okay.
So
I wasn't crazy. I know I'd seen it somewhere.
Right. So, I mean, maybe it's worth, to go along with the QST article, it might be worth cleaning this up, updating it, and making it static, and taking it off of Google Drive and actually making a hamsci.org page out of it.
Yeah, there were
Right.
we noticed in the acronym department missing at Hamsci that got frequent questions.
Yeah.
But
there's another CDAR actually has an acronym page. It's called the BAG, which BAG is a TLA that I can't remember.
See, you ought to name it TLAs or us.
Yeah, I'm trying to. I think they have it on their website somewhere. That's up acronym. Here it is, Bishop's acronym guide. So they update it. So there, I put in the link in the chat, a link to that.
Okay. I'll take a look at all that and try to figure out what to do with it, and obviously ask for help where I need it. So
Yeah.
okay. See what else was going on here. For those of you going to the Hamvention, we are going to have business cards to pass out, eyeball QSL cards actually. And we've got the design completed, and actually Randy KB3IFH sent me an approval copy yesterday, and this is what we'll look at. So we can have pockets full of these things in our lab coats, and then hand them out, and hopefully get people to follow our link and get involved with the Solar Eclipse QSO party. I think the idea partially came along from you, Bill. I know you asked for something to hand out at Orlando Hamcation, and we had a little flyer, but now we'll have these cards, and we'll have enough for a Hamvention, probably Tapper, DCC, and then Orlando Hamcation next February as well. So hopefully these will help stir some interest.
Yeah, I put them out in those places where people put out flyers and things, several different places, about 100 of them. And I noticed that most of them did get taken. So maybe we got some publicity that way.
Okay, good. Okay, the next thing I had is that we were looking at the form for the Grape 2 locations last week, and I did modify it a little bit with everyone's input. I noticed I also changed the upload requirement to approximately 1 gig per day, so we lost an order of magnitude, which is a good thing. And I put a comment in there that be aware that with slower connections, the daily uploads may consume a significant portion of your capacity, just to give people a little bit of a heads up. But I think that was a big change.
Yeah.
So that's sitting there for when we need it. Let's see what else. There was one other thing I wanted to show on whoop, real quick. Just to make everyone aware, because I know this group was highly involved with it, is Steve Serwin and I have been working on a page to put together some framework around the time of flight experiments he's been talking about. So far, I've got Steve's been helping me with how to prepare before the ellipse, suggestions on radios, links to the software. We'll get a sample of the chirp file up here and so forth, general methodology. And then I think the suggestions been made that we actually do some test runs a month before before the eclipse, so some people can get involved and make sure everything's working properly. There's also a lot to be figured out and how we're going to report results and scoring, if you want to call it that. Some references, and there's a lot of papers on what we've been talking about here. And maybe we don't need this map any longer, because initially I was thinking we would just want people on either side of the eclipse path. But Steve's saying, yeah, that's useful, but people along the path and even some distance away from the path are equally useful. So maybe this will stay, maybe it'll go, not sure. But anyhow, just want to make people aware we're working on that. And
That looks
that's
great.
about it. Yeah, that's about it for me. It's oh, the other thing is too, I did put up a post yesterday, the NASA Citizen Science page, a news blurb about the recently published paper on the crowdsourced Doppler experiment. So the NASA folks got back to me right away, Mark Kuchner, and he says, we've got a freeze on web page updates. So it may be later in the month or even May before they're able to post some of that. So, but at least it's in their queue.
Did he say why there's a freeze?
No.
Okay. I know they were talking about doing, you had to submit that PowerPoint with all these different HamSci things. So it sounded like they might be redesigning the website. So.
Yeah, that could be. And then Sarah Curran is out, so she's got a family leave issue too. So I mean, that's one of their resources. It's a little bit occupied at the moment. So.
Right. But we do have that paper posted on the HamSci website. So I have a nice little blurb about it up there. Sounds good.
Yeah. Any other Hamvention style updates? Sounds like we can move on to our Grape update.
Okay. Let's get this to fit. Oh, come on. There we go. Now, first discussion. Where's screen? Oh, there's the screen. No, that's not it. Trying to share the screen here. Try to think and nothing happened. Okay, here we go. This was some work I was doing yesterday in preparation for bringing Bill Blackwell online for programming the Pico. Bob Benedict's going to be programming the Raspberry Pi 4. This is sort of a block diagram of what we've changed into with the new requirements for the data capacity. I've got to clean it up a bit, but it gives you an idea that the level of interaction between the two computer systems is pretty significant. And yeah, we got a lot of work to do. I'm planning right now using a 2 terabyte solid state drive, but I haven't really priced them out yet. I know the 100 or 1 terabyte, they're under $100, but that's where I'm at on this. Bill has an initial piece of code that actually creates the data stream from the Pico to the Raspberry Pi 4 that he just started working on. He's got an initial version working, and we're going to build on that because that's really the crux of getting this whole system to work, is this little data link between these two USB ports. That's going to be handling it's, I think it's a 10.4 megabit. If I remember right, it's quite a significant chunk of bandwidth for a standard USB port. Well, not really that much, but if you've got it continuously going, it's really going to tax the operating system trying to queue it and keep up with it. So
Yeah.
that's the basic prop. So that's where I'm at on that. Bill, I don't see him on here.
Yeah, I'm on.
Oh, there you are.
Yeah. Hi.
Hiding in plain sight. So I've got to get this one cleaned up and get that out to Bill. And then I'm going to have to, I have a command set that the Pico is going to have to run. And since the one USB channel between the Pico and going over to the Raspberry Pi 4 is going to be solid with data, the command set, the back channel between the Raspberry Pi 4 and the Pico is something Bill is going to have access to. We're going to send commands, probably 1 or 2 character commands to this, and then we're going to have a hardware handshake back, either because the sequence is going to be the Raspberry Pi sends a command to the Pico and then raises this command line. He then executes the command and it says ACK or NAC. That way there's no back channel that we have to try and extract responses on the data channel, because that would be a nightmare.
Yeah. Hey, John.
Yeah.
This looks fantastic. This is looking, as far as I can tell, this is looking good, but I'm thinking a little programmatically here. What's the BOM cost on the Grape version 1.12?
The BOM cost?
Yeah.
Like I don't know off the top of my head.
Like 50
bucks. $50. I don't know, something like that.
Well, plus the Bodner.
Plus the Bodner. Yeah.
Yeah. But I'm wondering, I'm wondering to give us a little more time or two, because we really want to get a network set up before the October eclipse, right?
Right.
What if we, we're starting to identify locations. What if we got all of those people who are going to be running these stations running Grape version 1.12s, and they get their antennas in place, they're collecting, Grape version 1 data, and then that way, when you get the Grape 2 ready, all we have to do is ship them the Grape 2 board. They'll already have a Raspberry Pi set up, that we ship them a Grape 2 board and a hard drive, and then they just plug it into their existing setup.
That's definitely a possibility.
And then like we still want to get the Grape 2 out in time for the October eclipse. That'll be our goal. But
so another option would be, because I mentioned this before, is I could spin the Grape 1.12 that plugs onto the Raspberry Pi and has the U-Blocks GPS on it, which would be, then you wouldn't have to buy the Leo Bodnar.
How hard would that be?
That's probably a week or 2 worth of work. And then I probably have to rely on Bill, since he is the resident expert on programming the SI 5351.
But the main advantage, the main advantage of doing that would be we'd save, $75.
Right. But it would derail me for a while to create that.
And which is actually a big, I don't want to derail you. So I don't want to do anything that takes your, so 75. Okay. So basically we would save so if we were going to field 35 of these stations and we saved $75 a board by not using the Leo Bodnar, we'd save about $2,600. I don't think that's really worth taking 2 weeks of your time and distracting you. I think
agree. I agree.
So what I propose, because we could have you keep you totally out of the loop of getting a Grape 1 network essentially set up, because you have everything documented for doing the Grape version 1.12 boards. You have the BOM posted, you have the thing up. We have people who have experience actually building and running these things. So we can have those people handle figuring out where these things are going to go, what types of antennas they're going to use, all of that. with essentially keeping you out of that so that you can just focus on doing this.
Okay.
And then what that does is it basically will guarantee that we'll have a working Grape network before the October eclipse. And then and then when this is ready to go, we just ship them the new board. They just take out the old one, put in the new one, test it. They already have their antennas ready to go. They're already have node numbers assigned. You know, a lot of that overhead work is kind of done.
It also gives Gary a chance to get his distribution list figured out.
Yeah.
And I'm also thinking, instead of buying a resonant antenna, which I realize we don't need a resonant antenna, we just need pieces of wire, which means we go down to an $8 balun and 15 feet of 18 wire, and we got an antenna. So that knocks out about $75 for the total cost of everything per station.
Yeah. So I'm proposing then, let's see. So then how much would it cost us to send everyone 35 people all the stuff they need for a Grape 1?
If you're including the Raspberry Pi, that's going to be the problem.
Well, okay, but the Raspberry Pi,
buy those, but again, I have to buy them in quantities of 100.
But the Raspberry Pi, we only have to buy once. So the idea is that we get the person set up, they get the Raspberry Pi 4. So they now have, so that cost that we originally allocated to the Grape version 2, we're not losing it. We're just sending it to them early. So I don't really see that as being a problem.
And with the new Grape 2 send out, we would send them a new SD card for the Grape. They would just plug it in and it's plug and play.
Yeah. So, I mean, really, I'm just doing a back of the hand estimate. The cost to send someone everything they need now, the cost difference, because now what we're planning on doing is we would send everyone a Grape 1. So you get a Grape 1 board, which is like $35, plus a Bodner, which I'll say is $125. Let's see, plus add in, that brings it to $160. Is there anything else that they would need that is not already accounted for in a Grape 2 kit?
You're going to need the cable that ties the SMA to the whatever your antenna wire is. The power supply for the
Pi.
Pi.
Uh-huh.
Although I'm running
but they're gonna need the power supply for the Pi, whether they're doing the Grape 1 or the Grape 2, right?
Yeah, the power supply for the Grape 2 is going to be a little beefier, and it's a USB-C connection. Although if we have to ship them with, because the Grape 2 is actually going to provide the power to the Pi.
Oh, okay. Well, okay, so let's say
power supplies are cheap. You're going to need the SD card,
right?
Sound card.
and then the sound thing. Those are $4.
So the $35 for the bomb plus 100. Okay,
I can sort of get a real quick list to you and send it to you.
My guess, I'm guessing that $35 for the bomb plus the $125 for the Bodner comes out to be $160. That if we add in another $40 of overhead, I'm guessing the main difference would be like $200 a station to get that out right now.
Yeah, the Leo Bodnar then becomes a throwaway. Well, I hate to say that, but yeah,
no, it's not a throwaway. It's a supply. It's a usable supply.
Where are you going to get the pies?
Well, that's it. The Case Western is a registered distributor for the Raspberry Pi organization, and we can order directly from them to get the pies. Well, the catch is I have to order a minimum quantity of 100. And for the Raspberry Pi 4 8 gigs, those are $75 a piece. So you're talking $7,500. If we get the 4 gigs, I think they're roughly $35 to $40 a piece. So that'd be $4K. And I had proposed that to you, Nathaniel, a couple of weeks back, and you asked what my budget was for everything else. And that's when I started adding things up. And the only big thing I don't know about right now, the costs for building the board, I've got it pretty well under control because I have all the semiconductors, which are the expensive parts.
Mm-hmm.
So the build is probably going to be, I'm guessing for their assembly is going to be between 35 and $50 a board.
Mm-hmm.
Times the 50 boards. And there's going to be 2 of them. So it's times 100 boards. So that's $3,500 or $5,000 for that. And I definitely have that. So if I went and bought the pies, I think I'm all right. Because I think right now I'm sitting somewhere around 15K left.
Okay.
I sent my sheet to Salisa, and then she sent me hers back to check it again. It's like, oh, I was hoping she would check it. So we're playing bingo on that one.
Yeah. I would say
I can look into create real quick. I can create a bill of materials cost and a station cost, because I think the Bodnar is like 149 a piece now for in single quantities, but in quantities of 10, I think they drop a little bit. And I can email him and ask him what a price quote would be for 50.
Okay. Because I think what I'm proposing right now is that we build up the network with the Grape version 1.12s, right?
Mm-hmm.
And then that gives us a real safety cushion, because then if you get everything done in time, we just ship everyone the Grape version 2, they plug it in, they already have their antenna set up, they already know what they're doing, they're already in the system, we have a roster. And so, we could get them those Grape version 2s just a little, by like September or so, because everything else is in place.
Right.
And then what happens is, and let's say for whatever reason, you're not getting the Grape version 2 to work, you're,
something comes
who
up.
knows, something comes up. Okay. We're not sunk. Because then and this is actually written into the proposal. We wrote into the proposal that if there were any problems with the Grape version 2, we would go use the Grape version 1. And so this is actually a contingency plan that was written into the proposal. And
so it's fortuitous that it came out with the version 1.12.
It was beautiful. So, and I think what we should do is we should try to set this up so that we use as little of your time to build out this network as possible.
Yeah. Because I'm just about getting over the hump. And once I get this board out, then it's going to fall into Bill and Bob's laps.
Mm-hmm.
But I have to keep them coordinated. And I'm going to start up most likely at least once a week Zooms with them to keep everybody on the same page and on track to keep this project moving forward, because this is highly integrated with the hardware.
Right.
And there's tricks that they don't know about that I know about that will make life a whole lot easier, because I've done these command interpreters, and what we're after is a high reliability command interpreter. And most people don't know how to write those. And I've done 2 of them because you have to be fault tolerant and you can't have this thing hiccup. So
right.
There's some software tricks that I'm going to have to explain to them. There's simple things and in common sense, but if you've never done it, it's like, oh, I never thought of that. So
right.
I like that idea. So I'll put it on my list to get to you today, a quick listing of pricing for that proposal. It'll take me probably an hour.
Yeah. So I guess the thing that we have to figure out is what's the cost difference between what you're originally doing with just getting people Grape 2s to a new plan where we get them a Grape 1 first and then we ship them the Grape 2 later.
Basically, you would be not using Leo Bodnar and the sound card. Everything else is reusable.
Right.
So that's really the cost of doing that. Right.
So I think so my back of the hand estimate was tops $200 a station.
Yep, that's about right.
So then if we do 35 stations, that comes out to be $7,000.
Yeah, my build was still planned to be 50.
Your build, okay, which is great. But to meet the requirements of the grant, I think we said we were going to do 30 or 35.
Yeah.
So the requirement is actually lower. I mean, we could try.
I mean, I think if we got 50 Grape 1A stations, these new Grape stations from Gary's distribution list. We get those out there. He's got shipping addresses. He's got connections to people to talk to them. I mean, that whole infrastructure is now in place, and then popping in 2 is going to be so much easier.
Yeah. So we
That makes
have
a lot of
to,
sense to me.
okay, great. So if we were to do 50 of the Grape 2s, that would be a 10K difference. Can we absorb that?
That's going to be straining my budget.
Right. So there might be other places that we can look for that.
I mean, if there's possible other resources, we also have the
There are possible other resources.
ADRC.
ARDC. Well,
ARDC.
let's try to stick within our NSF
Okay.
for the moment. Because every time we write another grant, it's a whole other layer of complication.
Oh, well, the ARDC is pretty reasonable.
They
So,
are, but let's just take a look at this for a minute here. And actually, Rachel, we were having a discussion with Rachel about buying a laptop for her with Dr. Zorman, and Dr. Zorman was reluctant to take the laptop out of the case budget because he said that they could use that money potentially for other things. So I'm looking at the.
No, I think it was more the laptop could be used for other things, including the work not for the grant. So he said it was tricky to buy like permanent things with the grant.
Oh, I don't. Well, that's a whole other debate.
Yeah.
we don't have time for that today.
Yeah, no, we don't have time. I think we try.
That budget be untouched at the end
What's
of.
that?
I said that means that part of the budget might be then untouched.
Yeah. Okay. I'm looking at budget spreadsheets right now, and I don't know, John, if you can, do you think you can come up with a number of how much additional you need in order to figure out how to make this work?
Okay.
So you know how, so that's
the
the real question.
unknown is I don't know how much the boards are going to cost to be made. That's the big thing.
Which one is that? The Grape
RF
2
board and the controller board, the 2 boards for the Grape 2.
Okay.
I've got like the control of the costs for the parts. Specifically, I've got all the U-Blocks receivers, which are $100 a piece.
Uh-huh.
So that's $5,000 off the budget right there. And I've got all the other stuff that's not unobtainium. So I'm in good shape.
Okay.
So,
I'm also redoing the budget for the current personal space weather station grant. So including some of these costs in that grant may be appropriate.
Okay.
So, but it'd be really useful. I guess this is the one thing that I'm going to derail you on.
No, this is appropriate.
Okay. Is if you can figure out how much additional money we need in order to make this plan work, then
Actually,
I can
look at it from the backside. What do we have to purchase that's extra?
Right.
Be the sound card and the Leo Bodnar.
Yeah.
So that's, I mean, I'll go and review my list of things to do, because you still have to have the antenna.
Right.
You still have to have the power supply. You still have to have all the other stuff. So
yeah. So if you look at, because you know how much money I told you had so far, right?
Yep.
Yeah. So I need to know how much money on top of that we need. And that includes like shipping costs and stuff like that. Okay. Because we have to actually get all this stuff out. Because then if you tell me how much additional you need, I can go look at the spreadsheets and figure out where we can reallocate things.
Okay.
And possibly include some of it in the rebudget of the current DAISY grant.
Okay. Actually, there's a website I can go to and throw the board in, and well, the parts costs are going to be a problem. Yeah, that's the big unknown for me is I don't know how much it's going to cost to
Yeah.
where it's made. That's something you just pull out of the air.
Hmm.
Because of the hand assembly with the hand soldering for the sockets and stuff adds cost.
Right.
Can't do my machine, and that's where it gets expensive. So
Mhm.
Hey, John, this is
Yeah.
Dave in Colorado. I had a
you're awake?
yeah, I'm awake. Had a quick technical question. The filter for 15 megahertz on the version 1.12, is it wide enough, do you think, to be able to receive CHU?
Yes. Yes.
So I could configure it to do a CHU measurement here at Fort
Yeah.
Collins.
Yes, and that should already be in the code I've written for the bash or the aliases are in there for that.
For the Bodner?
The Bodner and the 5 megahertz should be able to receive, or I'm sorry, the 10 megahertz should also be able to receive CHU 7.85.
Okay, the filter's wide enough?
Yeah, it won't be as big a signal, but you should be able to receive it fine. Yeah, that was what I presented to Hamsai. I was showing what the filter widths were and the PU of the filters and all that kind of stuff. But yeah, it's in there. And you should be good to go.
So, Gary, I think the result of this for you is go full steam ahead on trying to generate an interest list of people who want to field grapes. Okay. And when you field this, you should say that, this is an interest list. We're not guaranteeing that we're going to send you something,
Right.
but we would like to know your interest and capabilities for doing this. And then that'll give us a list of people we can pick from that will. So it's basic. So basically people are kind of proposing, it's almost like a little mini proposal of why they should receive a grape. And I think the main factors that would go into why they would receive a grape are include location. So we'll have scientific needs as to places we actually have to have them. Let's see. And then quality of site. So like we'd probably be prioritizing people that are in RF quiet locations versus, noisy urban environments. And then we would have to also, willingness and ability to maintain this station over some period of time, at least through the eclipses. Preferably, the next step would be really we want, through the 3 years of this grant and potentially onward.
Got it. Okay.
The other update I got is I finished this, which I don't know if anybody could see it. Can I get it in there? Yeah. It's basically a board that plugs on the Raspberry Pi.
Mm-hmm.
And you plug a Pico into it, and it programs it directly.
Nice.
And it also will handle the Pico W. I've made another version with the programming socket in different position. Bill is going to be getting his today. And this is in support of the Grape 2 development.
Mm-hmm.
So basically, this Pico plugged into the USB port on a Pi is this link here with the cable is the high-speed link that we're going to be doing the fundamental development on this. So this is basically the entire development system without the Grape, but it has all the essential stuff for the high com stuff, which is the critical path. And once we get that in, fleshing out programming of the two 5351s, which Bill has done, should be a piece of cake. The magnetometer interface, Bob has that code from Dave Witten, I believe. And then the code for actually creating the header file and stuff I'll just pull that out of what I put in FL Digi, and that'll get Bob going on that for the new day stuff. So it'll come together pretty quick. We've got a lot of stuff that's been written and working already. It's just pulling it all together and making it sing together is where I'm at. So it's not if it's going to get done, it's when it's going to get done. So
Hey, John,
yes.
did you send that short wire?
Yes, I did. Yes,
Okay,
I
thank
did.
you. I should
I also,
expect that today.
that board also has the capability of tying UART 0 and UART 1 of the Pico into the Raspberry Pi UART port, which is kind of nice. It's jumpers.
Correctly. Okay.
And I have the jumpers on there, but they're not plugged in. This assumes you're using a Raspberry Pi 4 in a case like this to be able to wrap this cable around?
Actually, I've got a Pi 400, but I've got a GPIO extension card, so hopefully it'll work.
Yeah,
Right in.
I did send you the cable and the board and the Pico. So
Great.
it should be
Thank
running
you.
I think when you get it. And I
I've
just
got
tried
3
loading
extra
yours and-
Picos, so
yeah, I just tried loading yours and the compile failed. So it was,
okay.
I think it was the SDK link, and my LS USB disappeared on the Pi for some reason. I haven't figured out why. So
We should talk later, maybe today.
yes, yeah, we should. I want to set up a weekly meeting, but we'll get offline. We don't need to talk about that now.
Yeah.
Back to you, Rachel.
Here we go. Does anyone have any other questions, comments, concerns, updates? Because I think that concludes business.
Yay.
Okay. Are we good, Nathaniel? Do you have any other updates?
I'm all good, I think.
What are you doing in your free time?
Free time?
Who has free time?
I don't know. I want to buy some.
I don't know.
That's not in the budget.
I think I think it's all coming along. Okay.
Hey, John, is the Raspberry Pi image updated to have to cover the aliases that you mentioned?
I actually put that in 2019. Those are all up there. They're in there.
They're still in there when
You
you
should get into the command line, just type alias and you should see them all.
okay, cool, thanks.
Also set it up if you want to run it right at the frequency. You can actually, with the low IF conversion, you can actually listen to it as a radio. It's kind of funky, but it works.
Okay.
Let's
Okay.
see. I think we're good.
So I need.
So I guess
I got my
I
homework.
guess we should wish everyone a happy Easter. Very
Yes.
happy and a happy Passover for people who celebrate that, which I think is like David. And are there any other things we should wish people happy or good or something like that?
Happy
I
health.
think we're about in the middle of Ramadan, aren't we? It's about to
That's
start
right.
too, so.
Hope everyone's if you celebrate Ramadan, I hope you're having a good Ramadan. I know we'll be celebrating Easter over at my house, so very, very exciting.
When's dinner?
Sometime Sunday afternoon, I think.
Once your kids get into the algebra range, you need to start marking the eggs with X's and just tell them to go find X.
That's right. There it is.
True mathematician.
Where's X?
Solve for X.
Yes. Yeah.
Translated find X.
Yeah. I think all of this is going really well. I know it gets a little stressful sometimes, since I think the two things that's most stressful about this is the fact that we have this deadline of the eclipses that we really can't move.
We've got some insight that I don't have.
Yeah, that's one of those things that we can't move that. And the other thing is, I think, some of the bureaucratic deadlines of just trying to keep up with, making sure we have results in time to file reports and keep the NSF and NASA and all of those people happy. But
I do.
What's that?
I do have a question.
Yeah.
What is the new data rate or bytes per day? I know that you guys worked on the requirements for the Grape 2. What is the new, how much data going to be generated per day according to the latest design?
So my estimate is 10 hertz per channel bandwidth that we need out.
That has to be processed to generate that.
Yes. So I guess I can give people an overview of what John and I talked about last week, so you can see what we're thinking.
But the hardware design is already done, and the bandwidth that I'm sampling at is 4 kilohertz channel. So we'll have to subsample that or somehow filter that but that still generates the 10.4 gig per day. So we have to find some way of processing that maybe on another computer before we send it into your database to whatever you want.
Well,
but the raw files will be there as that.
Okay, so let me. So this is my understanding of the system. I should have just saved the one from last week, but we're going to insert. I wish it would stop adding all these little things that pop up. I know how to use PowerPoint. I just want to use it.
Ooh, ouch. No, let me show what I just said. Oh, can't do share. Okay, never mind.
Oh, what were you?
Odnar is listed at $156 a piece.
Oof. That's why I kind of think so. That's why for this phase one where we're just deploying, that's why for deploying the Grape version 1s, I might consider just doing 35 sites because that'll reduce the cost requirement there.
Yeah.
And that will also, it'll both reduce the cost requirement while simultaneously meeting what we said we would do in the grant. So that's why I propose that we just do like 35.
That makes more.
And then we also already have a network of Grape 1s already in place. So,
right.
You know, we don't necessarily need a whole bunch more.
We might not have to do 35 for that to fill out the path because we've already running. And since we're creating the same data, it probably doesn't make sense to replicate them.
Right.
Duplicate the effort. So actually we can fall back on what we have as the installed base to start from and figure out where we need to flesh it out for what we want for the experiment.
Exactly.
I think I might be able to tell you how to reduce the 10 gig down to the 10 hertz per channel on the Raspberry Pi. I believe it's possible to do that with a background job that will run once a day. And then you have something that can actually be uploaded through DSL.
But we'll still have the raw files on the terabyte drive, which I think is going to be important for Nathaniel down the road, because then that'll allow him to look for WWV and WWVH, which we can't do now, and all kinds of things we haven't thought of, because the full bandwidth will be there for your analysis for days to come. And with that, having that with the Eclipse, I think is going to be very important for future analysis because we don't know what we're looking for yet completely.
I do agree with that. Certainly for the Eclipse days and like a couple of days, you know, before and after, you know, some control days as well.
Yes.
And then what would be nice about that is like if we can't do that on an everyday basis, well, okay.
The data will be there. We're not going to delete it. And worst case thing, I was thinking about this. What we could do is when the drive's starting to get full, so we ship out another set of drives, you plug it into the other port.
Yeah.
And we have probably a software way on the Raspberry Pi 4 to switch the drive position. So at the end of the day, it switches to the other drive, you unplug it and you ship it back.
Yeah, I just don't know that we're actually going to have like ourselves the bandwidth to maintain that data rate every single day. Like if we can, great, but I don't know that that's really.
Well, that's why having each node keep its own data and then send in what you want.
Yeah.
So I think that makes a lot more sense.
I agree. So, all right. So let me see here. So my understanding, doing this off the top of my head. So we have the we have a mixer. This is the GPS DO 1 kilohertz below desired frequency.
Oh, you've been in the vectors, huh?
And then this is going to be a low pass filter. And I was going to say this low pass filter, well, what do you currently have it set at?
Right now it's set up for 2.5 kilohertz. From what your setup there is that you can't really go much below that because of your mixer product is a kilohertz.
Right. So that's 2.5 kilohertz. So then we need A to D. So this has to be a 5
Right.
5 kilohertz. Right.
Yeah.
Hold on. Give me 1 second. I'm just gonna grab some water. So all right, so this would give us 2.5 kilohertz of bandwidth. And if we had that, that would give us
I'm double checking on that bandwidth on my PowerPoint presentation here because I think 1 sec. Where are you?
excuse me, I'll be right back again.
Yeah, it looks about right.
Okay. A to D 5 kilohertz. Now, let's talk about this number for a minute. Really, let's get another text box here. So I think the minimum viable bandwidth requirement is really only 10 hertz per channel. What this will do is I don't think I would be okay surprised if the Harrier Doppler shift ever exceeded this value based on what I've seen in Grape data so far.
I agree. But Nathaniel?
Yes.
I agree with that. but with only 10 hoods, can we distinguish between WWV and WWVH?
No,
I'm getting to that.
yeah,
Okay,
Okay. Okay. So pro. So pro con distinguishing between WWV and WVH is ambiguous.
yeah, that
Um,
you have to have a minimum, you have to be able to detect the 1.2 kilohertz ticks. So that pushes your bandwidth from 1 kilohertz to 1.2 at a minimum,
mhm.
in addition to the 500, 600, and the 400 hertz flopping around are on different schedules.
Mm-hmm. Um,
So again, but this, for the experiment of purely just the Doppler shift, I agree 10 hertz bandwidth will meet the requirements now. But down the road, for any other experiment that's not just looking at Doppler shifts, this will not will meet it, which is where I'm saying the saved data on the SSD drives will be invaluable, because now you can go back and reprocess and get what you want.
I do agree with that.
Because right now that, cutting it down, that's post-processing, that's all that is. Because I can't change the hardware. I've given you the best possible opportunity for, with the mixer and the low IF and the low pass filter and the ADD sampling. I can't do any better than that right now.
Right.
But what I'm giving you is should be adequate for a very long time, especially if I'm giving you the full spectrum saved on solid state drives that in 5 years say, oh, we want to look at this such and such, but we need to look at it this way. You can't predict what you don't know. And that's
Right.
having that is invaluable.
I agree with that.
But for
Desired.
now you want to get something, because I was talking with David, and on a 1 second tick, since we have the one block of data, if we were to actually post-process that and create the 3 Doppler shift numbers for each second, we could mimic what Grape 1 is putting out now with 3 channels continuously.
Right. I agree.
And that he's figured out a way to do the FFT or the processing that it's a couple of narrow bins. It's not the full 8 kilohertz bins. It's narrowed down to, because we know where we're looking for the frequency. So we can make that processing time quicker. We might be able to pull off creating the 3 files that I'm generating now from the Grape 2s and push it into the same network, the same path, the same upload, same everything.
Right. Which would
And
make
that's
Christina very
megabyte a
happy.
day. That would make Bill Hancock have to take the duct tape off his head.
Mm.
Not to mention the tinfoil hat.
Yeah, but you gotta keep that on. That's still dangerous.
Okay. So let me choose minimal bandwidth.
For the Doppler
To
shift.
see Doppler variations. Okay. So, and then let's say minimum bandwidth to disambiguate WWV, WWVH.
That's gonna have to be 1.2 kilohertz for the ticks.
So really, and we probably want to have a little headroom on that, right?
Yeah.
We probably want to.
Yeah, because you're 3 dB down if you put it there. So that really wants to be 2.5, 2.4 kilohertz for the 1.2.
2.
Which is at the full bandwidth, because I'm actually sampling at 8 kilohertz, so I got a 4 kilohertz bandwidth, but I'm rolling off between 2.5 and 2.8, somewhere up there. So I have the bandwidth to see it.
Mm-hmm.
But I'm also not excessively sampling the thing to death.
So this.
So what I've got is exactly what you're looking for.
So you think 2.4 kilohertz bandwidth is the minimum that our filter can handle to see that 1.2 kilohertz
You wouldn't want to go down there. You'll be able to see it, but it's going to be attenuated and you're going to be in the roll-off region of the filter.
And if we set this here, we're not in the roll-off region of the filter.
You're getting into it, but yeah, I'm looking at my graphs. They peak at, my optimal frequency is actually 600 hertz and it's down like 10, let's see, it's down 30% at 2.4 kilohertz. So yeah. So, yeah, I have it to see it, but you can't go much beyond that. But that's the worst case scenario for what we'd have to measure if we're looking for those 1.2 kilohertz ticks.
Right. Can used 100, was it 1,000 hertz and 1,200 hertz tones to tell difference between WWV and WWVH on significantly more bandwidth.
And there's another technique you haven't looked at yet, and that's the time of flight, because we have the reference tick, and these are synchronized to 1 PPS, so we know when that signal's coming in. That's another way to determine who you're listening to, because WWVH is going to be way later than the WWV signal by probably a good 10 milliseconds.
Mm-hmm.
WWV. That we can take care, and that'll show up in every second's epoch.
Right. So it's like,
again, that's another post-processing thing that we haven't studied yet, but you need the full bandwidth to be able to do that.
mm-hmm.
Because your resolution of the timing is going to be based on your sample rate.
Yeah. I mean, I think even looking at just the carriers, you could potentially tease out useful information. It's just going to be much more difficult. Which that's essentially what we're doing now. You know, we're basically making the assumption that with the single FL digi measurement, we are, we're assuming we're seeing WWV.
And I'm already working with David on trying to come up with this fast filter to see if I can get Bob to code that in there. Because if that's the case, we just continue sending the normal files up.
Mm-hmm.
And data will then stay on each one of the Grape 2 stations. And then at some point in time in the future, we just trade it out, the hard drives. That's right. 10 gig is too much for anybody's backbone right now. Nobody has fiber.
I agree. It's too big for that. And it's too big for us to save all that data on a daily basis too.
Yeah.
So there's two reasons why that's just difficult.
Rachel, do you have to go to class?
I do not today. Class is postponed till 4:30.
Oh, okay.
I do have another class at 11:30-ish, so. But I don't think you're going to take that much time.
You hope not.
There's one other piece of information to disambiguate that would require less bandwidth. It's just more complicated. Okay. And that's if you look at the broadcast format for WWV, on the top of an even minute, you have either a special announcement or a 500 hertz tone. And the top of the odd minute, you have a 600 hertz tone. And for WWVH, it's reversed.
Right.
So we could, as long as you keep track of, are you on an even or an odd minute, which we are doing, you could conceivably narrow the bandwidth down to just capture these tones, and you're still able to do the disambiguation.
So 600 hertz, if you wanted to be safe, would be 1.2 kilohertz. So you're still in the same ballpark, roughly. It cut the bandwidth about in half.
But that's it. That cutting it down from 10 gigs a day to 5 gigs a day is a huge difference.
Well, my sampling rate still has to remain 8 kilohertz, so I don't alias. It's just post-processing is going to do that.
Right.
I can't change what I'm saving.
Unless unless you made this analog low pass filter be more narrow, but then that reduces the capabilities
And
later.
that eliminates other possibilities for testing down the road, which I
Right.
don't.
Right. So the ideal situation, yeah, the ideal situation is that you're able to keep this low pass filter, and then, you know, we do all of the other stuff digitally down here.
Right.
Right. Which is what you're trying to do.
Nice thing about doing post-processing in the digital format is you don't add noise. Numbers don't get noisy. Analog numbers do.
Using 1,000 and 1,200. Wait, say that one more time. The nice thing about doing it in digital is that the results don't get noisy.
You're not adding noise to the numbers.
Right.
Whereas if you do it in analog, you're adding noise to the audio chain.
Yeah.
But there's a cost for that. I mean, it's a trade-off.
Right. I guess the question's going, so assuming you can make all of this work, the real question is going to be, how much data are we actually going to save? That's going to be, because you think you can actually make all of this work, John?
Well, that's what I have now.
Yeah.
And if Kasdan can come up with the post-processing to do the 1 second epoch eval of the frequencies for the 3 channels, and if we can get that to run in real time, we can then, in addition to saving the big file, is creating the 1 second tick Doppler shift files that we're doing now with FL Digi.
Right.
We won't be losing 2,000 sample seconds every day like we are with the FL Digi.
Well, my whole intention with doing it, say, this way, is there's no reason you have to do what David is doing in real time. You can do that.
Correct.
You know, so as long as, if we get either this one, or that one, we can generate, you know, those files that David wants from these files.
Well, all of it's generated from the raw data. So once I've saved the full spectrum data, all of that is possible simultaneously.
Right. So so even this one, if you just have this option, you are still able in post-processing to do what David wants to do.
Yeah, because that would be post-processing.
Right. So I guess in terms of, you know, David's thing, I don't like that. To me, that I don't see why you would want to run that in real time on the system, because you could do it if we can make the system to at least do this, because then you're just adding more cycles to the system that you could do in post-processing.
Well, the issue becomes, does the Raspberry Pi 4 have enough horsepower to be able to do that while it's saving the raw data? Because right now, we're just getting the data system to save it. Once we get to that point, then we can start benchmarking to see how much extra processing power we have.
Right.
And we're probably going to dedicate one core to this operation.
I guess what I'm saying is, why spend any horsepower on any Raspberry Pi horsepower on doing what David is trying to do? Why not just do that on some more powerful computer after the fact?
It would have to be local and not over the net, or not over to Bill and have him process it. What we're trying to accomplish here ultimately is reduce the 10 gig data upload per day to something less significant, which is only done with post-processing.
Right. So what I'm saying is, why are we trying to do the FL Digi thing at all? Like this also accomplishes that goal of reducing the data that we're trying to get over to Bill.
Like, well, it adds another computer essentially. So you have to push it off onto something local to process it. If the Pi doesn't do it. Who's doing the processing?
Right, but why are we still trying to do the FL Digi thing?
It was just getting the Doppler shift, if that was useful. If you don't want the Doppler shift information, we don't do anything.
That's what I'm saying. I'm saying totally don't do the FL Digi thing. Just do, at minimum,
we would not be using FL Digi. We would be writing our own dedicated code to do that. It'd be a lot more efficient.
Right, but even that, like, there are so many problems using that algorithm? Why are we doing that?
When it's split, you're grabbing the highest peak and all that kind of stuff. So yeah.
Why are we spending our time
We're not.
implementing that onto the
We're
system?
not doing that. That's not on my plate right now.
Okay.
The only thing on my plate is to save the raw file to the solid state drive.
Okay.
Once we get to that point, then we have to decide what we want to do to send to Bill.
Okay.
We're not sending in the raw file. There's going to be post-processing involved. And then the question becomes, does the Raspberry Pi do that as a background task? And does it have the bandwidth to do it?
Okay.
And that's my main question. I don't know if it has enough horsepower to be doing this extremely high data stream and processing at the same time without having it hiccup on the data stream, because the data stream's the high priority task.
Right.
You can't screw that up.
Right.
If the post-processing screws up, who cares? We just go back and do it again.
Yeah. And I guess what I'm suggesting here is let's just say we get to the point where you're working on this and you're like, I can't make the hardware keep up with this data stream. Let's say we get to that point. I'm suggesting, well, maybe we could reduce using 500 and 600 hertz tones. If you just can't get this thing to work, then maybe we consider reducing the analog low pass filter to something a little bit more narrow, like the 1.2 kilohertz. And then now our plan, then that reduces your A to D requirement and the data stream requirement. And then we can still potentially disambiguate WWVH using this technique. It's not as good. This is certainly the best over here. But if you're banging your head against the wall and you're just not able to meet these requirements, we can essentially cut the requirements in half by going down a level.
In the next couple of weeks, Bill and Bob are going to be able to help me answer that question. Because if we can get the data stream, this all becomes a moot point. We've got the data saved. Now we just have to get everything running. So that's where I'm at right now. And I've seen parts of it work already. I think Bob had said he had gotten, but it wasn't the full data path. I want to get the whole data path working. And that's why I'm hemming and hawing and saying that it's not working yet. Because to me, it's till I see it working, I'm not going to declare it, because that sends a whole bunch of other things into motion that shouldn't be set into motion yet.
Right. Yeah.
I don't want to. Yeah, I don't want to do that.
Yeah. No, I agree. And I'm just, all I have here is, so I think you should continue doing what you're doing. Yeah. I'm just trying to lay out a viable plan that if you run into some roadblocks that just you say this isn't going to work, it's like, okay, we can do useful things.
Processing chain you have in front of you is already working.
Right.
That's all there. The only question is whether we can save the data. And there are some techniques we haven't tried yet, like storing it in binary instead of hex ASCII, which would cut the data rate in half. So like I say, I've got some other tricks up my sleeve, and Bill and I are going to be working on that probably right after we stop talking here. But yeah, I'm fairly confident, about 85% confident I can pull this off.
Okay. That sounds really good.
It's just, it's a tough slog because it's way out of the wheelhouse of where I was originally with the Grape design.
Right.
But it sounds like the Tangerine is still not squeezed and produced and shipped yet.
No. And what we're expecting the Tangerine to do really is, I think, very different from what we're trying to do here with the Grape anyway. So I want the Tangerine to be able to emulate what the Grape is doing, but I have much different ideas for what the Tangerine should be doing besides this.
It's good to know.
It's like, it's a very, very different thing.
Okay, good. That's good.
Yeah. So you don't have, there's really not any sort of conflict or.
My mantra on marching on this is to keep it simple. That way it's more flexible down the road.
Yes.
And I'm keeping it as simple as I possibly can.
Yes, I agree with that.
Simpler is also more reliable.
Absolutely. So I'm going to put this in this Cedar Eclipse Grape brand. I'm going to say, let's see, I think I have well, I've got to organize this better, but I'm going to say Grape. So I have a Grape storage requirements. Excel sheet, Grape, bandwidth requirements and simple block diagram. Call it that. And what I've been doing to do, I have this other spreadsheet here, not that one. This Grape storage requirement spreadsheet. So what I'm able to do here is I plug in something like how much bandwidth is going to come out per channel. So right now we're saying 2.5 kilohertz. Okay. And we have 3 channels. So then that means that every Grape, and so then calc generates 2.5 gigabytes per day. And that is accounting for
That's not accurate because I'm creating a 16-bit word for each sample.
Let me try this spreadsheet instead.
Okay.
Okay. So 2 bytes assumes 16-bit sampling.
Correct.
All right. Bandwidth per channel, 2.5 kilohertz. 3 channels. Total bandwidth is 7.5 kilohertz. So that's this times that. Okay. Bytes per sample per day is 2 bytes. You have to multiply by 2 because we're using IQ.
How are you doing that?
What's that?
How are you doing that? Oh, double sampling. It was my sample.
Double sampling. So
Okay.
this, you can either call this
That's
the IQ factor, either the IQ factor or the Nyquist factor.
Got it. Okay.
Okay. So I'm accounting for that Nyquist.
Yep.
Okay. And then bytes per second. So that's going to be the total bandwidth times 2 bytes times 2 for the Nyquist. And then I have times 1,000. Why do I have the times 1,000 in there?
That would be per second.
Per second, but why is that 1,000?
Samples. Yeah, it should be 8,000. Well,
because I have total bandwidth. We're trying to save 7.5 kilohertz worth of bandwidth.
because I have with my 8 kilohertz sample rate times 2 bytes per sample times 3 channels, I get 48 kbytes per second.
48 kilobytes per second.
Yeah, you've got 30 kilobytes there. But my sample frequency, your sample frequency is 2.5.
This 1,000 is because this is in kilohertz.
Oh, okay.
Okay, that's where the 1,000 comes from.
Okay.
It's accounting for that. This is kilohertz, so that 1,000 takes that and multiplies that by 1,000. Okay, so now what we're doing is bytes per second. So we have 7.5 kilohertz.
Now that's a bandwidth calculation. That's not a sample calculation.
Okay, yes. So that's the bandwidth calculation, but then you multiply that by the IQ factor of 2. So that gives you the number of samples you need.
For that bandwidth, right?
For that bandwidth. And then you multiply that 2, saying we're using 2 bytes for 16-bit sampling. Okay. So then that tells me that we're generating 30,000 bytes per second.
Yeah, it's a 5 kilohertz sample rate.
At the 15 kilohertz sample rate.
Right, but I'm actually at 24 kilohertz because I'm sampling at 8K, not 5K. That's where the discrepancy comes in. My hardware is doing an 8 kilohertz sample rate. You're making the assumption here it's doing a 5 kilohertz sample rate. based on the bandwidth of the channel, not on the sample rate of the sampling.
I see. So
That's where the disparity between 30 and 48K comes from. It's the difference between 5K samples per second and 8K samples per second.
okay, so you're doing 8K samples per second.
Right.
So you're saving
4 kilohertz bandwidth.
4 kilohertz bandwidth.
Yep, that's it. That's what the Grape 2 is now doing.
Okay. So we have this is what the Grape 2 is currently sampling, right?
If you multiply that by 86,400 seconds per day, you get it's roughly 4.15 gigabytes.
I have so what I did was I said this is how many bytes per second, and I divided that by 1024 squared to get this 0.05 megabytes per day. I mean per second.
Second, yeah.
And I multiplied that by 3600 to get megabytes per hour. And then I multiplied that by 24 to get megabytes per day.
Yeah, and that's just the raw data. That's not anything to do with, that's if you're storing raw numbers or binary numbers only with no information with it.
Right.
Yeah, do you have to put timing marks in there or something?
Yes, I have timing marks in there, and there's a checksum for each second.
Yeah, so you got to account for that.
Yeah, it doesn't add much, but but the big difference here that I came up with the 10 gig is I was storing the data as each byte of data would have been 2 hex ASCII characters. So that's where it goes from your 3.9 to roughly 8 or 9. And then when you add all the other stuff in, it comes out to just about 10. Times 50 grapes. Wow. That's a lot of data. You're going to need exponential notation for that one.
So we're looking at 135 terabytes per year for a network of 50 grapes. So, let's see. If we take this and we say post-processed values, and we say, okay, let's say in post-processing, cut this down to 2.5 kilohertz per channel. Then we're down to 2.4 gigs per day. And then for the whole network, we're looking at 84 terabytes per year. And if we bring it down to...
Again, that's if you store it as raw binary numbers only.
Right. We brought it down to 1.2.
I mean, it's not human readable anymore.
But we may have, for this, we may have, that's probably,
I understand.
that's just what we're going to have to do. And then, yeah, to make it human readable, we have some software that, then converts it to something like David Kasdan's FL Digi.
You would basically double, because you would need 2 characters for every binary byte.
Yeah.
At a minimum.
Well, another thing you can do is when doing here's how I would do it. In post-processing, you convert it to digital RF, that also compresses it at the same time, and you can read it with HDF5 view. So
you lose the timing marks.
No, you don't. No.
Is there timing stamps in the digital RF format?
Yes, digital RF can keep track of all that if you code it up right.
Yeah, it's actually specifically designed to do that.
Yes. So.
And so I think this is where we have to figure out what's actually tractable. So you can imagine because like you have, then there are two sorts of, I guess there's like at least 3 different bandwidth requirements. One is the bandwidth requirement. Maybe I'll write this down here in a new slide. Bandwidth requirement types. And then there is, so you basically have one, what the Grape hardware is capable of handling. 2, what the user's network is capable of transporting. And then 3, what we are able to store for the long term. Because like, at least in today's world, I don't see us, with our current level of funding, I don't see us being able to sustain this on a daily basis. Okay. Maybe we can sustain this. Maybe.
But with
I
processing,
think,
do whatever you want. Yeah, you've got all kinds of options.
yes, but even with post-processing, at some point, we have to have a place to store this stuff permanently.
Right.
And if we don't have a place to store this stuff permanently, at some point you have to say, okay, we're going to just throw away this data just because we don't have any place to put it. And so that's where, we say, I think this is where the low cost part of the station comes in. So yeah, if this were a high cost station, we'd keep everything. But, can we do the science that we need to do just at this level? Because if you do it, if you're able to disambiguate things enough, even at just that level, all of a sudden, if you change this down to, if you change this down to 0.01, let's see, that's what 10
hertz.
10 hertz, right?
Mm-hmm.
Now all of a sudden, if we can scientifically make that usable, then all of a sudden each grape is generating, is that right, 10 megabytes per day? If you save 100 hertz, you're generating 100. Yeah, if you're saving 100 hertz of data, you're generating 100 megabytes per day from each grape. And that is way more, that 100 megabytes per day is way more useful than the FLDigi product. But then you have to play.
Topless shift is the only thing you want to do. Yeah,
that's right. So then the question is, can you actually disambiguate what the transmitter actually is? But now we're getting, at this rate, we're really getting into something where it's like, okay, we can actually store that on a commodity hard drive and process it easily. Give everyone gets a whole copy of the entire 50 Grape network. Or what happens if this jumps up to 500 stations? Well, you're still within a realm of, okay, this is useful. And if you're looking at, if you have 500, stations of their data, you might be able to disambiguate just by looking at the whole network. Similarly, what if we were able to, on the Grape itself, what if the Grape were had a WWV and a WWVH flag? So basically it was set, so you give 2 more bits of data. You said if the Grape can automatically detect the difference between WWV and WWVH, it sets it for true. If it detects WWV, it sets it for false if it detects WWVH. And then you only send this 10 hertz worth of data plus those 2 bits for if it's WWV or WWVH.
One
Then
way
you're
to
still
do
within.
that would be, since the GPS knows its exact location, you can now do time of flight calculations, since you know the location of WWV and WWVH,
Yeah,
and you could use that to discriminate as to who you're receiving,
yeah.
because it's a
And
huge difference.
you can also do, and they do this on spacecraft a lot too. You can have triggers that put it into a high bandwidth mode. So it's like if you're going along all day and you're basically not seeing anything interesting, or the geophysical indices are low, you basically just give this level of data. And then all of a sudden, if you see all this variation and things are going kind of haywire, there's a big geomagnetic storm, the thing automatically kicks into a higher bandwidth level.
Again, that's all post-processing and
Yeah.
review
So
that.
so
That's
I think your approach, if you can actually do it, I think your approach of being able to save this level of data does give us the most flexibility. So if you are able to get the hardware to work at this level, and then we can do the post-processing to select what level of data afterward, that's the most flexible.
Yeah.
And
that's what I'm shooting for, and that's I think we're going to end up with. So,
well, that would be amazing. But I think it's also nice to know that there are these other paths for down sampling and making the data tractable.
yeah. Again, that's all post-processing stuff. On my now, hardware is fixed at the 8 kilohertz with the 2.5 kilohertz bandwidth.
Yeah, and I think that's perfect.
Okay, and that's what you're going to get.
I like it. Well, I think we went over a little bit, but I think we had a really good discussion here about the data requirements and everything. We'll look forward to seeing those numbers of how much more you need, John, for doing the
yeah, the tricky part's I have no way of guessing what it's going to cost to assemble the boards.
And you're talking about assembling the Grape 2 boards, not the Grape 1 boards?
Oh. No, I'm not. I'm talking about the assembly of the Grape 2.
Okay. I think for the Grape 1 boards, we could the New England Grape Group has very graciously volunteered to help in any number of ways. And they've included like setting up a shipping line. They seem to be good at building these things. So I think it would be reasonable to ask them if we provided them with all the equipment for the Grape 1s to send them all the equipment, and they would take care of building them and shipping them out to people.
Okay.
And we could even give people the option, do they want to build a Grape 1 themselves, or we just send them the parts, or do they want a pre-assembled board? And because there are people who really want to build this stuff themselves, so they might just be like, yeah, send me a Grape 1 board. And yes, even Todd Crisell says I'd be willing to build some for you, about 3 per day. So I think for getting those Grape 1s, I don't think we need to include the build cost in there. But yeah, obviously Grape 2 we do.
So what I need to get you is how much extra cost it's going to be to implement a Grape 1.1 distribution of, say,
30 to 35 boards.
30, yeah, I'll say 30 to 35 boards.
Yeah. And then we'll aim for a Grape 2 network of 50. But I think if we get a Grape 1 network of 30 to 35, that'll minimize the additional extra cost we need while still
But I think I would throw out to but my mind just went blank. He's not on the call here anymore.
Gary,
thank you. Jeez. All the things I've lost, I miss my mind the most. If he could convolve that with the existing stations, we might not have to put out 30. We've probably got maybe at least half of those already.
Exactly.
So that drops the number down even more.
Yeah,
I can give you the cost per station.
What we need to consider though is where those stations are located geographically already.
Great. And that's his task, is to figure out where on the path and how to get a hold of them. That's
yes. Yeah. So you don't have to worry about that.
Yeah, that's his problem, not mine. That's a big one.
Yep. Yeah.
Okay, I think I've got this. So the extra cost of distributing the extra grapes over what we would normally be doing.
Yeah.
Okay. I will get that to you, hopefully. I think I should be able to do that today. Well, I guess a couple senior projects coming up, so. Always something.
Yeah. Oh, I know. Of course. Yeah. So I don't think I'm not going to be able to respond to it till after Easter probably, but
Oh, okay. So I shouldn't
So-
want to get it off to you today.
no, I'm going to be baking Pasco with Anthony today.
Oh, okay. That's important. Definitely more important. That sounds
Yeah,
like
much more important, right?
that sounds like fun.
Yes. So
Question is, how much will he be wearing when you're done?
that is a great question. I don't know the
This
answer.
requires some significant research.
Yes, I agree.
I envy you. That sounds like fun.
Thank you. I hope you have a great day.
Everybody have a good Thanksgiving. You guys all take care.
Bye. Happy Easter.
Happy Thanksgiving, I mean Easter, 73.
73.